Lesson 27 and Lesson 28 is dealing with percentages and how percentages are used in the real world when you go shopping. Whether it's a discount or a sale price, they usually take the discount based on percentages. So the reason why I think this warm-up is important is that you have to realize that when you go to the store and you buy something and there's a discount, you wind up paying less. Sales are good. The reason why I'm kind of emphasizing that you pay less is that after you're done doing these word problems, you want to look back and see if your answers make sense. We've had students in years past, they'll go to a store, there's a pair of jeans for $50, there'll be a 10% discount, and then in their final answer of what they'll pay after the discount, they'll write down $5,000. Doesn't make any sense. Why would you go to the store? First of all, no pair of jeans, unless of course you're a celebrity, because designer jeans, I guess, that's, thousands of dollars they pay. But you're not going to go to the mall and pay $5,000 for a pair of jeans. So look back to make sure that your answers make sense. You're going to wind up paying less than the original price. Okay, so example 1. A sweater is regularly priced at $32. Underline that. And it's marked 25% off the original price. I want you to underline 25% and also the words original price. What will the shopper save after the discount? Remember we were doing part-to-whole relationships? We're going to break it down. The original price, is that the part or is that the whole? The whole, right? The price that you pay after the discount is considered what's called, it's the part. And you just got to always remember the idea is that a part plus a part is going to equal a whole. So if we now break this down, the $32 represents, as Riley already stated, that's going to represent the whole. You can circle it if you want. You don't have to write it. You can if you want. Or circle it. What about 25%? Is that the part or the percent? Mallory. Right, percent. If you see a percent sign, don't read into it more than you need to. It's the percent. Therefore, what are we trying to find? Correct. Now I'm going to introduce you to something new. What we are going to really wind up doing to figure this out is make a little mini equivalent ratio table, and here's how I want you to set it up. There's going to be 3 rows and 2 columns. So why don't we do this? Let me draw it all out first, and then once you see the whole thing, I think it's easier for you to copy it down. Do you see the difference already? Yeah. You have 2 parts now and 1 whole. Don't draw anything yet. Don't draw anything yet. Now I've added that first column. If you want to start now, you can. Okay. So you have in parentheses part. The first part's called saved. The second part's called paid. The third is the whole, and that's the original price. There's still more coming though. So. Okay. Now I'm going to make 2 columns. The first column is going to be dollars for money, and we're going to do a column for percent. And now I'm going to just make the lines, and you'll see it'll look like a little equivalency ratio table when we're done. That's what it looks like. Can we close that door? Now we just have to plug in the pieces to figure out where the whole, and then you'll see once we plug in all the pieces, there'll be pieces missing, and we got to figure out the pieces missing. Got a question for you though. There is one of these 6 blocks that you could fill in right away that would be the same for every single time you do this. What do you think, Lauren? What? Well, before you even look at any word problem, there is something you can fill out right away without even looking at one single word of the word problem. Do you know, Taylor? You're looking at the word problem. Don't look at the word problem. Yeah, it's always 100% no matter what you are doing. Where does it go? On the right, where? On the bottom. It's like your free spot in bingo. So no matter what problem you're doing, you're always going to have 100%. Yep. Because it's the whole, right? Think about what the 100 is. It's the whole, W, percent. Matthew.
Another box we could also fill in the top first box in percent for 25.
Yeah, but that's coming from the word problem, which we're going to do next. What I'm saying is this 100 here can be filled in before even looking at the word problem because it's always going to be 100 no matter what. Now I do have to look at the word problem, and we'll tackle the percent first. You have a 25% discount. So what you have to decide, this is the new part, is that 25% that's discount, is that representing what you save or what you actually pay? Aiden, it's what you save. So now watch, you have to find the saved row and the percent column. 25 goes there. Now I'm not going to look at the money just yet. Once you have this and this, there's another box that automatically falls into place every single time. What also can be filled out? Adam. Where? Yes. Okay, I was going to ask, how did you know that? Well, we know that this number 25 plus this middle box has to add up to 100. So what do? You could probably do it in your head, but technically you're taking the 100 and you're subtracting 25 to get 75. So this goes here. Now let's take a look at the money. A sweater is regularly priced $32. So that 32 has to go in the money column, but which of those three? Original price. That's the whole amount, right? Before you take off the discount. So I'm gonna, how much was it? 32, right? 32 goes here. Now here's where the math comes in. Because there's no other information in the word problem that I can plug in. I have to figure this out using math. Shannon. No, because that's the original price. When you go to the store, you're going to wind up paying less after the discount. What you save is what's being deducted from the original price. All right? Which we still don't know what that is. We have to figure it out. They're asking us to figure out how much would you save and then how much do you pay. We've got to be able to figure out one of these two boxes using math. What can we do? Craig. Could, but there's an easier way. Look, what did we do back when we were doing template ratio find? We're looking at either constant or multiplicative structure. Is there a connection here between 32 and 100? Can't use constant, can we? Taylor? That's a connection. See, we're going to take 25, and now we have a multiplicative factor of how much? 25 times what makes 100? I keep blocking you, I know. times 4, right? So watch. Think of it almost like TRF, and make believe that middle row is just missing right now. What number times 4 makes 32? 8 goes here. Okay. See, so you just made the connection. Once you have 2 out of 3 here, you can automatically figure this out right over here. And how did Adam, how did you do it?
So 32, I think I divided, and I know 8 goes to 32 4 times, 20 times, 25 times 4 is 100. So,
Wait, I lost you.
so
How did you do this? Because you just called it out, this middle one, this part paid. It's good. Do it again. I'm not going to say that you're wrong. I just want to hear it again. We're trying to now figure out
20,
the paid.
25 times 4 is 100.
Yes.
8 times 4 is 36.
Yes.
So 8 times 3 is 75.
Okay. So what he did, okay, I never thought of it that way. You can now also connect from here to here. And he said, oh, times 3. And did it that way. Well, what's another way you can do it? Dylan? Right. Remember, part plus part makes whole. So you could do 32, take away 8, and you get 24. So now, going back to breathing some life into this question, you go to the store. It's $32 original price. There's a sale discount of 25%. How much are you saving? How much are you paying at the register? Make believe it's tax free. There's no tax. You're paying 24. So by doing it this way, you wind up being able to answer both questions at the same time. Aiden. If you do that, it will work. I will tell you this: you start to run into issues when you get into lesson 28, because lesson 28 is going to kind of ask the question in reverse, and it gets confusing. You're not going to be able to just take your percentage, change it to a decimal, and multiply it by the whole price to get the discount. It does work here. It works throughout 27. It will not work for 28. All right? So now, I know this is the first time you're seeing something like this, and you say, oh, geez, it's just too complicated. Just give it a chance, because anytime you see something new for the first time, I don't expect you to get it right away. We're going to practice it. Anyway, let's answer these questions, and then we'll go on to another example. And then I know I have questions over there. Some people have their hands raised as well. So how much are you saving? And then the next question is, what are you paying? And that's $24. Let's practice it again. Okay? Next page. An important part of all of these questions will be and always continue to be is that you do have to identify what's the part and what's the whole every single time. So now we have a pair of jeans that was 30% off the original price. The sale resulted in a $24 discount. What was the original price of the jeans before the sale? How is this one different? What are they asking us to find now? The whole, right? Okay, so 30% represents what, everybody? Percent. 30% is the percent. It's right there. So don't, like, again, if it's 30%, it's percent. But what does the $24 represent? The part this time. Therefore, they're asking us to find the whole. So we got to set up the matrix again, which takes time. I know that. So it's part, whole. Then it's saved, paid, and watch what I do want you to do. Do OP for original price. It saves a little bit of time. And then you need a column for, got to bring this down a little bit. Oops, I don't want that. column for dollars and make a column for percent. So it should look like that when you're done. Okay, what was the percent that they gave you? Well, what always goes here? Lower left. Lower right, I mean. 100% always is free spot. What was the percent that they gave you? Is that what you pay or what you save? That goes saved and percent. That automatically gives us one other number that we can fill in right away. Mallory, 70. Automatic. Once you have 2 out of 3 blocks, you always can get that third block using subtraction. Okay? Shannon, you good? Because they have to add up. If this is 30, this plus this has to equal 100. Or 100 take away 30 is 70. Part plus part equals whole. Yup. Part plus part always equals whole. That's from the word problem itself. It's right there. Right there. Okay. Okay, well that's the question now. Is the $24? We've already identified it as the part, right? But is it the part you save or is it the part you pay? Is it the part you save or the part that you pay? Addison? It's the part you pay. That's what you're paying at the register. So that goes here. So, now, can we connect anywhere? And I say connect. I mean connect without having to use a decimal. Can 24 go into 70? Can 30 go into 70? Can 70 go into 100? Uh-oh, now what? Think back to what we did in the previous lesson when it didn't fit. Riley? You have to scale this down. But watch, here's why there's a little bit of an extra wrinkle. You've got to scale down all 3. Okay, because these are all part of an equivalency ratio table. So if you're going to scale 2 of them, you got to scale all 3 of them. But it's kind of easy with this because what number goes into all 3? 10. So if I divide this by 10, and I divide all 3 by 10, now I've got 3, 7, and 10. And guess what? Look. I found the mistake. You can, yeah, the 24 is what you save. Because look, let's go back. Watch. The sale resulted in a $24 discount. That's what's being taken away from the original price. I'm saying this should work, and this needs to go here. That's the mistake. But now it will work. We have a constant of times 8. So look, guys. Sorry about that. Does everybody see now that we can multiply by 8? What's 7 times 8? Now, if I wanted to, I could add these 2 to get this, or I can multiply my 10 times 8 and get, and then just check it. Is 24 plus 56 80? It works. So 30% is always a good discount. You're going to get, that's a Black Friday deal right there is what that is. Okay, so go back and visit the original the question. The original price before the sale was what? guys. The original price. Yup, $80. How much does the shopper save? Or how much does the customer actually pay? Yes. Oops. You want to try number 4? Set it up. Do this for me. Set this up before you do any math. I'll help you out with the template. And then I just want you to plug in the numbers where they belong and show it to me.